Welcome back, everyone. What an incredible morning. Some amazing presentations from some amazing people. We are live streaming all talks to YouTube, and recordings of each talk will be available for people to watch after. So be sure to check that out at ChainSafe's YouTube channel. We're also live tweeting the event. If you are on Twitter, which I know many of you are, do us a favor, give ChainSafe a shout out using the hashtag CSCON. Index one. If you could do that, that would be most appreciated. We have 6 more presentations planned for today, starting with our very own CTO, Greg Marco. Greg will be speaking about the future of Web3.js. Greg, why don't you turn on your camera and mic and join me on the main stage? Hey, Greg, how you doing today?
Good. How are you doing today?
I'm doing excellent. The stage is yours.
Awesome. Just give me a moment here. Somehow I got left with doing Twitter and YouTube today. So just making sure it's all set up. Oh, this is weird. It's sharing my external monitor and my computer as one screen. Oh, there we go. CSCON. Wicked. All right. I'm looking at the chat. Are we good? Awesome. Cool. Welcome, everybody. Thanks again, Dustin, for putting this all together, and the rest of the crew at ChainSafe party planning committee that made this a reality. I'm super excited to kind of talk about one of our newer Ethereum ecosystem projects that we're contributing to and maintaining, Web3.js, and I'll kind of get into that a little bit, details a little bit of that a little bit. And today I'm here to talk to you guys about the future of Web3.js and where we're planning to take it. So quickly, a little bit about me. Camera is awful. Basically, I'm the co-founder, one of the co-founders and CTO at ChainSafe. My background, I didn't really come from a CS background, economics guy, but, started doing development. And one of the first things I really did in Ethereum was work on forks of Geth for some clients and stuff. And then from there, my passion for like DevX and UX in general really took over. And that's kind of where I spent a lot of my time, especially in the ecosystem. I've done like little things like, add Control S to Remix so that it auto compiles your code and doesn't save the web page to your desktop, and, little things like that. Spent a lot of time building dev tools, and so like Truffle plugins and things like that, just things that help make our lives better at ChainSafe and know that it help make other people's lives a lot easier too. So that's why it's super exciting when, when we eventually started working on Web3.js, because it's, as you'll get to find out if you don't already know, it's one of the most used packages in the NPM or the Node ecosystem, and used by developers every day. So a little bit about Web3.js, get into that, and then kind of talk about our plans for where we're going to move it. So for those that don't know, Web3.js has about over 150,000 weekly downloads. We are peaking at about 200 back in October and averaging about 180 right now. And again, that's weekly, and it takes up a lot of time to make sure that, we got to get these builds out, that they're right and stable. So it's exciting, but also a little bit terrifying. And we also have 2,632 dependencies dependents as of yesterday. So that's like projects using Web3 that are published on NPM. It seems like a low amount for the amount of downloads, but one of the main reasons is like we're the backbone to a lot of the Truffle libraries, Ganache, and basically a lot of like developer tools actually use Web3.js under the hood, which is why basically where we get a lot of our downloads from. So whenever you do like npm install, Ganache core, you're pulling in Web3.js at the same time, just part of the dependency tree. So there's a lot of people relying on us, and it's important for us to take care. Yeah, briefly, just like for those that don't know about Web3.js, kind of like basically it was there at the beginning, 2015. A bunch of the early guys built it and started maintaining it. In about 2018, someone who's here, I think, Samuel, he started, really doing some intense refactors because the code base is old, it's clunky. And he also started kind of forming out what would be the vision for Web3.js version 2, kind of pulling it out of that endless pre-V1 state. Later on, Nomic Labs came in to really help stabilize the repository. Again, like old repo comes with a lot of baggage, and they eventually did that. And a year later, we came in back in about June, I believe, of 2020 to basically help take it off of the EF's hands and really just start developing, pushing it forward in a smooth path. And I'll get into kind of why we did that and like what made, why we're taking it over and why it's important to us. So kind of like what's next? Few things. One, TypeScript. TypeScript's super important to us. As Cayman talked about before, just before me, he, running the ETH2 JavaScript kind of like ecosystem. TypeScript's really good, important, especially for developers, so that we can get it, give them strong types that they can work with at least like, pre-runtime. Obviously, JavaScript doesn't have like that nice richness. But having that so you know what you're actually interacting with and can like expect like the expected outcomes of some of your like calls. Right now, it's like not written in TypeScript. It has declaration files, and they're all broken. We've tried to fix them, and fixing them is technically a breaking change. Leaves us with our hands tied to, do we do a major bump, minor bump, or just, let's just rewrite it. And really awesome to say that like it's in the process. We're almost done with a full ES6 rewrite. Those that aren't familiar, ECMAScript 6 is like just one of the newer versions of JavaScript. It comes with a lot of just like nice to look at things like classes. Versus using .prototype. And basically, Web3.js as is now is written in, pre-ES5 pretty much. And it's clunky. So one of our teammates is doing an incredible job right now and almost has it fully done. And really excited once we do that, we'll be able to migrate it fully into TypeScript piece by piece. Right now, the last 2 builds of Web3.js have actually been compiling using the TypeScript compiler. They just simply don't do anything because we use regular JavaScript files. Web3.js plugins. So this is actually super awesome, really applicable to kind of what we're discussing today. We've already seen a few different projects talk about their interoperability solutions as well as their EVM compatible sides. So that was Ava Labs, Avex with the C chain, as well as Ethermint, one of ChainSafe's other projects within the Cosmos ecosystem, both touting EVM compatible chains. Really interesting piece with this Web3.js plugins is that, we see a constant need for people that are always messaging us about adding EIP supports and different sorts of, functionality that isn't really core to Web3.js, because essentially Web3.js is just the Ethereum, like it's the interface to chatting with Ethereum or otherwise one of the Ethereum nodes. And it's hard to start implementing a lot of like specific EIPs, Ethereum improvement proposals, and find features. So after we get our ES6 plugins, our ES6 stuff set up, we're implementing a plugin system so that people can then go and plug and play their own modules that don't affect, that's not leaking the provider or any keys and stuff. It allows them to just basically extend the library, give their own community and their users the fine grain, that fine grain like granularity they need to interact with it, with that, whatever it is. And it's really applicable to all these other chains because, if there's something weird that you have to do to mutate a piece, like a variable pre-flight, you can do that, which is great. So really excited for Web3.js plugins. Probably in early 2021, we'll see that rolled out. This is like a hot topic for those that actually know Web3.js will know that, build sizes in Web3.js is quite the problem. We sit at about like 100 megs, I think, if I'm not crazy. Yeah, it's like huge. With the plugin system, we're actually going to be decoupling in what will be V2, the entire kind of Web3 object, so that you're only going to be importing the core pieces of Web3, which will dramatically reduce the build sizes, which is going to be huge because now you only have to import what you actually want to use. You don't need the entire word list because you're not ever interfacing with the mnemonics. There's no reason to import the entire word list for the mnemonics. it's going to be a huge benefit. It'll make it a lot lighter. Websites won't have like a massive bundle size on them anymore. A lot of this is design stuff that was taken from Sam's original work with the original V2 design, and we're kind of just redoing it ground up based on our new changes with the ES6 stuff, which will make it a much smoother transition. What's next? Oh, and better builds. Yes. Right now, builds are produced into the dist folder, and it's a disaster. We're going to automate the process a little bit and have, just better release management in general to ensure that, you guys are getting predictable builds. I cannot speak today. And okay, so my favorite topic, E2. For those that don't know, before Cayman took over, I was kind of like leading our Lodestar project. And then thank God Cayman came and, did what he did, and he's been doing an incredible job. But Web3.js, as of today, I believe it's coming out today, has is going to have ETH2 support. So we built basically the first plugin. Since the plugin system's not actually there, it's a standalone packages, but it's in the main Web3 repository in GitHub. It's a fully compatible ETH2 API, and it was built really seamlessly so that we can make updates to it really easily. If you go and use it right now from the release candidate, you want to get use it right now, you can. It'll allow you to fully interface with any nodes on ETH2. So that's Lighthouse, Taku, Prism, Lodestar, Nimbus, and pretty much any of them. It'll work as long as they're conforming to the API specification. It's super exciting because it essentially is like, the first official like Web3.js like package for ETH2. There's not a lot of data to query from the chain. Specifically, you don't get that rich like contract stuff, not just yet. As these things roll out, we're going to roll them out too, because our teams, the Web3.js team and the Lodestar team, are going to start working really close together to ensure that, we're giving them production grade ready APIs and provider libraries, so that while the Lodestar team starts prototyping their light clients, we can actually start prototyping with them. That'll be great because we'll be able to drive the developer tooling for ETH2, and at the same time, making it backwards compatible to what everyone's used to within Web3.js. Super excited about that because it'll really help push, get that like foot out the door for ETH2 dev tooling, and some good grounding there, especially when the light client stuff comes to play. That's pretty much it. I didn't want to have a super long conversation with y'all. If anybody needs to get a hold of me, whether it be for Web3.js releases or anything like that, or just in general, you can find me pretty much everywhere with @GregTheGreek, Twitter, GitHub, everything. And feel free to reach out to me there. Otherwise, also want to plug, ChainSafe is hiring. These are the 4 main positions we're looking for right now. You can always go to chainsafe.io/careers to find out the latest. We're always posting new stuff. It might have changed already since we started this conference. I have no idea, but Anna could let you know. And yeah, thanks for coming out to my presentation today. Quick little update on where Web3.js is going, and thank you.
Awesome. Thank you so much, Greg. I know you're busy, so I appreciate the time. And I must say, big fan of the beard. I think we speak for everyone to keep it growing. We got one Q&A question here for you. Is it planned to provide a functional API with V2?
Is it planned to provide a functional API with V2? I'm not really sure, but what the question is, but I'll do my best to try and explain. I'll look in chat if somebody actually owns up to the question. V2 basically plans to be a major breaking change, which actually breaks out all the core packages. So right now, Web3.js is made up, the main export imports a bunch of other libraries. One of those, like a bunch of those, like Web3.js core, Web3.js like accounts, Web3.js like, provider libraries like the WebSocket, the HTTP, all those, the XML ones. It imports a bunch of these different like sub libraries. I'm just looking at time. Okay, I'm good. And basically that adds a lot of bloat. So V2 aims to actually basically take the plugin system that will just be a major bump on the 1x branch. So it'll go like 1x, 4, 5, whatever it is, and do a full breaking change to 2 that will actually basically now make all those sub packages plugins. So now a user would actually basically import, like if they ended up wanting to use the wallet functionality of Web3.js, you'd have to import that and declare it as a plugin. A lot of people don't use Web3.js for more than just like querying calls. So there's no reason for you to actually need to, install all of that with it. Hopefully drive better adoption and lighter builds. And
one last question before we move on. What was the hardest part of transitioning into maintaining Web3.js?
Sorry, what is currently still the hardest part? It is the fact that we are writing. It's like you get a bug report while we're in the middle of like trying to transition all the code over from like pre-ES5 to ES6. And it's like just trying to understand what's going on because for those that don't know, there's this like keyword in JavaScript called arguments. It's like a catch-all on the parameters and it's used everywhere. So you can basically declare a function, sans parameters, and then throw in like an infinite amount of parameters in the function. And then you just do arguments at index whatever. That's caused us a lot of pain and suffering because like we actually don't know what's going on. So simply just like trying to actually read the code and understand what it's doing has taken a lot of time, like a lot of time. Previous maintainers, even when we read each other, like, yeah, I don't even know what that's doing. So we've got a handle on that. The ES6 refactor will hopefully fix all that because it'll make it class-based. And TypeScript will hopefully solve all that too.
Awesome. Thank you so much for the time, Greg. It's been an absolute pleasure.
Thanks, guys. Once again, we're hiring.
Awesome. Thanks, Greg. Go ahead and unshare your screen. I will introduce our next speaker. Excited for this individual, another dear friend of ChainSafe's, co-founder of CSCON, Marek Olszewski. Marek, why don't you join me on stage and share your screen? And how you doing, Marek?
Hello, it's really great to be here. Thanks for having me.
Absolutely. With that being said, the stage is all yours.
Amazing. Let me just share my presentation. Cool. Well, it's really great to be here. Hello, everyone. For those of you who don't know me, my name is Marek Olszewski. And today we're going to be talking about what's next with Plumo. Plumo is Celo's Featherlight snark-based syncing mode. And yeah, let's begin. Oh, and I also love the beard that Greg was sporting. This is the best that I can pull in terms of my quarantine look. I've been growing my hair out, desperately in need of a haircut, as you can see. So let's begin. So for those of you who are new to Celo, Celo is a new scalable proof-of-stake based permissionless platform. It's fully EVM compatible, and it makes financial tools accessible to anybody with a mobile phone. It launched earlier this year in April for Earth Day, and its mobile focus, I would say, is really what makes it kind of unique. And on that platform, C Labs, which is the company that I work for, launched Valora, which is kind of our flagship social wallet built on top of Celo, and it's now available for on Android and for iOS. It's now seeing growing usage in the Philippines, in Kenya, and also in Brazil. And you can learn more about it by going to valoraapp.com. And if you forget that there are 2 A's in Valora app, that's okay, we'll redirect you. And so Valora looks a little bit like this. It is modeled heavily off of centralized social wallets and really focuses on the payments use cases, kind of rather than the more traditional store of value use cases that you're seeing kind of in today's wallets. And we've been able to implement this and have it have kind of this experience that, again, kind of rivals centralized offerings. Really because of kind of 3 big kind of technology innovations on the Celo platform. The first is that Celo has a built-in kind of stablecoin platform, which allows you to create multiple stablecoins that are all pegged to different fiat, that are all over-collateralized and backed by the same kind of crypto asset over-collateralized reserve. These tokens are implemented as, or these stablecoins, I should say, are implemented as ERC20-like tokens on the platform. But critically on Celo, you can pay for gas using tokens. And so it's really easy to send and receive these things. Next, you may have seen kind of on this screenshot, you see a bunch of names and photos, really kind of underscoring the social nature of the wallet. This is really enabled through kind of this built-in lightweight identity protocol that maps hashes of phone numbers to public keys. So this means that you can find each other by phone number, so it's easy to send payments to people in your contact list. But also, if you receive a payment from someone in your contact list, then you can kind of indirectly infer their name, and if you have a photo for them in your contact list, you can also pull up a photo. And all of this is secured by kind of Celo's decentralized phone verification protocol, which during onboarding randomly kind of pairs you with other participants on the network who send you text messages, and you receive multiple of those, in effect, proving with high probability that you have access to a phone number. And really excited, as of this last release of Valora, C Labs now pays for your phone verification costs using meta transactions, and so it's free to get started, really easy to get onboarded. So again, highly recommend checking that out. And then kind of probably most interesting with respect to kind of today's talk, Celo really from the ground up has been built with kind of this mobile first mindset. We'll talk about the consensus protocol in a bit and how it's very efficient, but also there are other things like full node incentives that incentivize people to run full nodes to service like clients running on the network. And so I'm sure for this audience, this graph needs no explanation. These chain sizes have been growing obviously a lot. These numbers I pulled yesterday, 302 megabytes for Bitcoin, 574 gigabytes for a full node sync with Geth on Ethereum. Clearly too much data to download on a mobile device to sync. And on the flip side, mobile device adoption continues to grow. Some people kind of get surprised when they see just how big these numbers are. Last year, there were 8 billion mobile devices, not including IoT devices, that had active mobile subscriptions in the world. And this year, we crossed the 6 billion mark for smartphone devices with active mobile subscriptions. Again, that's just a staggering number. And it also really underscores just how big of a percentage of these mobile devices are now smart devices. I think feature phones are really rapidly, globally being completely eradicated. And then if you look at the colors of this chart, you'll see that the connectivity is also actually really impressive. So over 60% of these 6 billion smartphones now have LTE, 4G, or better connectivity. And by 2025, that will be over 80%. Again, really, really big numbers. And so mobile is clearly already here and continues to be kind of the future. And, obviously to Satoshi's credit, she kind of foresaw this and came up with kind of this simple payment verification protocol that many like clients today are based off of. The protocol is simple. You simply download each header in the chain. If you receive multiple chains from the network, then you simply pick the one with the most proof of work done against it. And once you get to the most recent header, then you can use a Merkle proof API to query state and receive proofs around state that you're interested in looking up. And again, so long as the network isn't being attacked and you can trust kind of that longest chain rule, then this works really, really well. But, you know, it's still a lot of data. Again, these are numbers I pulled yesterday, 53 megabytes of headers to get to the latest header on Bitcoin, 5.7 gigabytes for Ethereum. That is a staggeringly big number. No one's going to wait to download 5.7 gigabytes of data to get their app going, which is why, as I'm sure many people here know, most mobile wallets today simply trust a third party. And so if you want to build something that is fully permissionless and decentralized, you know, you can't really do it. And then it turns out that this also creates problems for cross-chain bridges. One way of building a bridge is to verify the like client protocol in a smart contract on the network. And that becomes pretty expensive as well. Not in all cases, but in many cases, as we saw with BTC Relay, which ran for a while on Ethereum, bringing Bitcoin headers onto ETH, which died around 2 years ago. And if you're interested in cross-chain bridges, my colleague James Prestwich will be talking tomorrow at, I believe, the same time. So definitely check out that talk as well. So yeah, so what's being done? You know, you might be wondering what's already been done in the space. You know, and there has been some related work. You know, in the proof of work space, Nipapau and Fly Client used interesting techniques to effectively reduce the number of headers that you have to download to a number that is logarithmic in the length of the chain. I think for Ethereum, this roughly ends up being around 500 kilobytes of data, which is definitely a lot better than many gigabytes. Unfortunately, these techniques don't really work in proof of stake settings, and so we weren't able to leverage them. On the proof of stake side, you probably have also heard of Coda, which is using kind of interesting recursive snark composition to effectively prove that a block and therefore a header is part of the chain. And this is very interesting. Unfortunately, there's a few trade-offs. Probably most importantly for us, it limits what you can do in the smart contract kind of setting. It's, as I mentioned, Celo is fully EVM compatible, and so if you want to maintain that compatibility, it would be quite difficult to be able to construct proofs that verify the correctness of an entire block and the entire execution of that block. And so in this work, we focused mostly on the light client, which again, for a use case of those kind of social mobile wallets is actually sufficient. And so how does Plumo work? You know, it works in the context of Celo's proof of stake protocol, which is similar in many ways to Cosmos. We use stake to kind of elect hundreds of validators who then perform PBFT-based consensus to kind of agree on valid state transitions in the chain. Validators effectively agree on such a state transition by signing kind of the headers or the header of each block that they validate. And so long as 2/3 of these validators sign off on a particular header, then it's deemed kind of validated and final. And so in this context, if you wanted to build a simple light client protocol, you can do so by effectively modifying the SPV algorithm that we just talked about. You download all of the headers since the beginning of the network. You can then use that to construct or to validate, I should say, Merkle proofs that full nodes send you. And then rather than just checking the proof of work along the way, you instead just check that 2/3 of validators signed off on each header. And then if the validator set changes, then you just need to keep track of those changes. In Celo, the result of the any validator election is encoded in a diff in the header, in addition to kind of smart contract storage. And so a light client can simply notice that there's changes to the validator set, apply those changes as they're kind of verifying these signatures. And so this works, but again, it would likely have kind of a similar amount of data that you would have to download to kind of what we see already today on something like Ethereum. Because Celo has even shorter block periods than Ethereum, 5-second block times, this would quickly become prohibitive for any mobile device. And so to improve on this, it uses kind of 3, I would say, new innovations. Number one, it uses kind of the concept of epochs, where the validator election can only happen in an epoch header or the last header in that epoch. And so for the current mainnet, epochs last about a day. And so an election can only happen once per day. And so this means that within that day, a light client can verify a header in any order that it so chooses. It doesn't have to download all of them. It knows the validator set will stay the same, so it can verify that 2/3 of those validators have signed off on that header in any order that it fetches them. And it also means that if it's syncing from the beginning of the network, it only has to download the last header of each day instead of every header, because that's the only time that the validator set can change. And so if you take a 1-day epoch length, and if you have 5-second block periods, then this ends up being a 17,000 times reduction in the amount of data that a light client has to download. So that's pretty significant already. Next, like some other recent networks that have launched this year, Celo uses BLS signature aggregation to aggregate the signatures that each of these validators are leaving on each header into a single constant size multi-sig and a bit vector of all of the validators that have signed. If you factor in the and this is by contrast to kind of some earlier proof of stake networks that just simply have an array of all of the signatures from all of the validators. And then if you factor in the rest of the header size, this results in roughly a 10x reduction in the amount of data per header. And so these two optimizations are what the network launched with. And given that the network has been around for on the order of 6 months, it's still very quick to sync. And if you spin up Valora today, it syncs with the network near instantly. But as the chain grows, that will change. And so what we're rolling out very soon is the use of snarks to effectively prove this existing light client protocol that I just described into a non-interactive constant size 500 byte size proof that mobile phones can verify in constant time to effectively make this much more efficient over time. And so what do these snark proofs have to do? For each epoch, they effectively have to perform kind of the light client protocol. This means that based on the current bitmap, you have to see which validators signed. Again, only 2/3 of validators need to actually sign. So if maybe one is offline and 99 sign, you would have to verify the signature of those 99. The way to do that with BLS aggregated signatures is you actually have to aggregate the public keys of each of those 99 validators according to this bitmap. That gives you the aggregated kind of public key. Of course, you also have to check the bitmap to see that 2/3 of validators did in fact sign. And then, of course, you have to check that the epoch number has in fact grown by 1. Then you encode this epoch into bits and hash to group, and then you can compute and actually check the overall BLS signature. And so we do all of this in the SNARK circuit, and that works for one epoch. But how do you prove this across multiple epochs? Ultimately, that's how we get this extra benefit from these SNARK proofs. We could do it in one of two ways. We could either recursively compose these proofs by proving the verification code that verifies the previous proof, in addition to doing what I just described on the previous slide. This works quite nicely. You end up getting a single proof that, or this could work quite nicely in that you would get a single proof that you could then verify, and you would know that the header associated with that proof was in fact in the chain. Unfortunately, verifying or proving the verification code is obviously quite complicated and requires either fairly new cryptography that hasn't been used in production environments before, or really big elliptic curves or cycles of elliptic curves that just would be prohibitively expensive to actually deploy in practice. And so rather than that, Celo uses a slightly different technique using the more conservative Grot16 proving system, which has been around for a while, has been used in Zcash most obviously, but as well in many other places. And instead of recursion, we use induction, and we effectively just prove a large number of these epoch headers in a single proof, almost sequentially, such that that proof then allows like clients to simply fast forward and kind of jump from kind of this one header on the left to the header on the right once they reach the header on the left. And so long as you can have proofs that allow you to jump a good amount of distance, then this really can be quite effective at decreasing sync times. The overall complexity is still linear, but your constants become much smaller. And so this is in fact what Plumo does. Because checking BLS aggregated signatures requires pairing operations, and because those are typically prohibitive in SNARK circuits, we employ a technique from Zexy, which uses kind of one level of recursion. We actually construct all of these proofs in the BW6 curve, which then allows us to efficiently construct proofs of pairing operations over the BLS 12377 curve that we use for actual signing of these headers. So that's kind of the summary. What does this end up performing like? When it comes to the proving times, they look roughly like the following. So where the proving times grow with the number of epochs and the number of validators. And so this number is for 150 validators and 135 epochs, which is just over a third of a year. And on Google's biggest machine that you can rent from Google Cloud, one that has 160 CPUs and 4 terabytes of RAM. This takes on the order of an hour and a half to construct one of these proofs. That is a big machine and a lot of RAM. And an hour and a half, it takes, is a significant amount of time. But it turns out that these machines, especially if you buy a spot instance of these machines, it only costs $6 an hour. So we're talking about $9 to construct one of these proofs. We only have to construct one of these proofs once per day. And as soon as really anybody on the network constructs one and gossips it out, then everyone can verify it, and it can be spread amongst the network, and it will instantly allow light clients to start syncing more quickly. And so the public benefit of that $9 a day is just enormous, and so it's easily amortized. And there are teams that are looking to do this in FPGAs. We also have some working graphics card code, so there are ways to even decrease this cost more, although really $9 is pretty impressive as is. On the verification side, it takes a constant amount of time to verify one of these proofs, regardless of how many validators or epochs are in them. And the numbers look like the following. On really the oldest device that we could find, I think it's 6 or 8 years old, I forget, one of these Moto G2s, it does take around 6 seconds. But on a more recent device, we're talking about on the order of 1/5 of a second to verify one of these. Very, very reasonable and significantly faster than having to download 1/3 of a year's worth of epoch headers. And then verify them, which also does take some time. Now, these verification results are slightly out of date now. These are from work that we did before on the SW6 curve, and we've actually migrated now to BW6, which is a much more efficient curve. And so these numbers are expected to be around 3 to 5 times faster. And the team worked really hard, but we weren't able to get these new numbers in time for this talk. But do stay tuned. These numbers will look a lot better soon. So some of you might be wondering what's new. Maybe you've heard about Plumo before. There's a bunch of really exciting things that I wanted to share as part of this update. Probably most critically, we are now code complete for all of this snark-based logic. It will be launching in the next Celo hard fork, dubbed Dona, which will happen in Q1 of next year. Really exciting. A lot of the code is now out for audit, and there's teams that are combing through the snark logic and the syncing code. So that's really exciting. With this launch, we're going to be adding new slashing conditions, of course, so that a validator can equivocate between the kind of snark and the non-snark data, and also for creating forks on the snark data. So that's exciting. And then perhaps most impressive, there's been a fair amount of work that has gone into optimizing the performance of this, both using some really interesting arithmetic optimizations, but also some hand-tuned assembly for x86, and now also for the Apple M1 chip as well, which is awesome. And then there's also, as I mentioned before, beta graphics card support. And it turns out that this work, if you look at the performance, wasn't really required for running the network for constructing those proofs. This work yielded kind of a 2 to 4x improvement in kind of proving time, but it didn't really matter even if proving took longer. We have ultimately 24 hours to construct those proofs, and those machines are still relatively cheap per hour given the public benefit of these proofs. But it turns out that these optimizations were needed because in addition to the proving time, the amount of time needed to contribute to a trusted setup ceremony for the snark systems also was quite big. In fact, before we did the work, it was on the order of 3 to 4 days that everybody would have to run their kind of fairly beefy CPU, fairly beefy desktop machines in order to contribute to the ceremony. And if you wanted 50 to 100 participants, 3 to 4 days times that, we were talking about very, very long periods of time needed to perform the ceremony. So we did two things. We did these optimizations. So now it's on the order of 12 hours to 24 hours to participate in the ceremony. And we took some ideas from Justin Vitalik to effectively parallelize kind of a Powers of Tau ceremony so that all of this computation can happen roughly at the same time, which then again really dramatically lowers the amount of time needed to do the setup. And so that setup, we just announced it. It's coming soon. So it's really, really exciting. I think by just the raw amount of computation that will be needed to perform the setup, this will probably be the biggest one done to date, and certainly the first one to be done in parallel, which is really exciting. It's going to be big because the circuits are big and because the BW6 curve is big. And so if you're interested in hearing more, definitely go to tinyurl.com/plumo-ceremony. There's a blog post there that outlines the whole thing. It's very interesting. And then if you like participating in these things, and I highly recommend it, these setups are effectively can be trusted so long as only a single participant acted non-maliciously. You can be that participant, and so highly recommend signing up. They're really fun to do. And if you're interested, definitely check out tinyurl.com/plumo-signup. Yeah, and so that's everything. I wanted to thank you all for being here. And if you want to stay connected, definitely check out the following links and my Twitter handle, which to save you guys from having to remember how to spell my last name, I recently changed it and replaced my last name with _, so much, much easier for you all. Awesome.
Thank you so much, Marek. 6 billion smartphones is a staggering number. And the work that you and your team are doing sounds quite fascinating, but very much so quite challenging. So thank you so much for the time today.
Absolutely.
We have a couple questions in the Q&A. First question, what technical developments are you most proud of?
Yeah, that's a really great question. So the Celo platform has so many different innovations that it's really hard to even spend 30 minutes going through them all. And so for this talk, I focused on the Plumo part. I think from a technical perspective, the Plumo part is definitely the most challenging. These are massive proofs, never been done types of proofs over really interesting kind of new curves, the BW6 curve. So definitely that's up there. The identity protocol, a lot went into making it practically impossible or effectively impossible to brute force the phone numbers and to infer who's using the platform. To do that in a decentralized way was very, very difficult and very interesting. And the end result is that you get a really beautiful user experience where you can send payments to people in your contact list. And so I would have to say that, maybe that just ekes out and is more proud of that.
Awesome. Another question here. What are the biggest challenges with a mobile-first blockchain platform?
Yeah, consensus for sure, right? This is the biggest thing, right? This is why most mobile wallets don't really try to do decentralized consensus or verify decentralized consensus on mobile devices. And so this was I would say, the biggest challenge.
Awesome. Thank you so much for your time, Marek. I'm very excited for the future of Cello. Thank you for your time.
Absolutely. It's great being here.
Thanks.
Have a good
Take care. Awesome. Our next speaker is absolutely brilliant. Yet again, another dear friend of ChainSafe's. There's a talk on IPFS and libp2p in 2020 from Protocol Labs, Molly McNally. Molly, how you doing?
Doing well. Can you guys hear me?
I sure can.
Awesome. Cool. Thank you guys so much for having us. This is really amazing. I'm really enjoying the talk so far.
Awesome. Well, the floor is yours.
Cool. Let me aim to screen share and let me know if it works. Okay. Success? You see my slides?
Success. Sure can.
Success. Thanks so much. Cool. Well, excited to chat with you all today. Wanted to give a fast lightning tour of all of the really exciting stuff that's happened with IPFS and libp2p in the past year. I think probably a lot of folks last engaged more heavily with IPFS maybe around the April-May timeframe when we had our big IPFS 0.5 launch. So I'll recap that briefly and then also dive into some of the cool stuff that's happened in Q4. So for those of you who aren't super familiar with IPFS, it stands for the Interplanetary File System, and it aims to take kind of the centralized HTTP web where many different end users must all connect to the same server in order to get the data to a more distributed peer-to-peer system where you can have subnets operating that are partially offline. You can have a much more flexible system of nodes directly accessing content on each other. The way it does that is by, instead of addressing location data by where it's located in the network using location, it instead uses content addressing in a global namespace to be able to move data around a network and uniformly verify that the data you're fetching from any random node in the network is the data you're looking for. And this aims to address a whole ton of different problems. It's been used a good bit in kind of either offline first use cases or in efficiency use cases or in places where you really need to verify that the data that you're timestamping into a blockchain, for example, is the data that you mean to. And there's a whole ton of security benefits that come with that as well. It also helps a lot in the resiliency robustness case of kind of links breaking because something got moved from server A to server B. When you're content addressing data, that same content will always have the same name. And that helps a lot in a ton of important use cases. And so there's lots of fun problems to solve here. IPFS is part of kind of this, what I've been colloquially calling the interplanetary stack, but this set of protocols that build on top of each other in order to make kind of a distributed peer-to-peer web possible. And so IPFS builds really heavily on top of libp2p. I'll also talk about a few folks who are using just libp2p, say, to power various blockchains that are have been launching over the past couple of months. It also uses IPLD, which is the data layer for how we actually form files and DAGs, distributed acyclic graphs of data that we can then move around the network. And then Filecoin also builds on top of this whole stack and adds an incentive layer for fetching and finding content in the network. As I mentioned briefly, libp2p is kind of this modular transport layer. And so it's actually made up of a whole ton of different sub protocols, which then fit into kind of finding and exchanging data with nodes within the network and setting up those sorts of connections. And is used super heavily. And a lot of the improvements that we made to IPFS over the past year actually involve kind of the deep changes and improvements within libp2p that then flowed into benefits up the stack in IPFS. There are a whole ton of people who are building on top of IPFS now. We actually have an open Figma diagram where anyone can add new applications to our IPFS ecosystem view. There's a ton of new ones here, all from kind of the content creator side with folks who are doing video or audio or other kind of content creator first networks on top of IPFS, which adds a lot of benefits around giving people more ownership over the data and not having to trust or be bottlenecked by a middleman, to more social media use cases, identity use cases, a lot of DeFi use cases. I'll talk about that briefly, and then a lot of really cool integrations and collaborations. So lots of expansion here, even just in the past year. And we also last year saw a lot of growth in the wider network as well. And we're excited to see that many of those nodes have also upgraded to our most recent release, which, or maybe since 0.5, which is our May release, a number of folks have upgraded since then. So we have hundreds of thousands of nodes in the network, many of whom are running the most recent improvements to IPFS. And we also, in addition to running kind of this distributed network of nodes, also run an HTTP gateway whereby we make the content living within these nodes within the IPFS network accessible over HTTP to all sorts of, classic browsers that are not yet IPFS enabled. And where we run one of many gateways, Cloudflare runs a gateway, a number of pinning services and other tools also run gateways like Pinata and Fura and others. Just on our little subset of this, we're seeing really massive amounts of people who are utilizing that tool, which demonstrates there's even more valuable applications building on top of IPFS and putting valuable content within that network and wanting to make it accessible and have a smooth upgrade path kind of into that Web3 world. And the data has also increased very precipitously, so lots of exciting data being used and shared there. So the main meat of what I wanted to talk to you guys about today were some of the awesome trends we're seeing in 2020 across this stack. Kind of starting with Q1 with the D-website explosion. A lot of amazing tooling here made massive gains and eased access to putting websites and web tools on top of IPFS, and so we'll talk about that briefly. Q2 is when we made a whole ton of performance improvements to IPFS, released our biggest upgrade to the protocol in a long time, which brought a lot of performance improvements to all different parts of the IPFS data cycle. Q3 was a lot of upgrading some of the standards, both within IPFS and the way that IPFS works in connects into other ecosystems, and making some new friends, bringing some new folks to the top of the IPFS stack and the application ecosystem. And then finally, what we've seen in Q4 with a number of new protocols coming out, either building on IPFS or libp2p or both, in order to kind of become, first level chains or other things like that. Cool, so jumping into things. One of the awesome trends that we saw really take off in kind of the February, March timeframe was uploading and making it really easy for people to add D-web sites built on top of IPFS, but easily accessible on the web. And a good amount of credit there goes to groups like ENS and Unstoppable Domains that made it really easy to upload a file and connect it to a D-web protocol so that you could have, momac.eth and easily resolve that in the browser and be able to serve a fully distributed page there, not running through DNS. Unstoppable Domains similarly created a whole set of templates where you could easily put up these kind of D-web websites in a really easy way. And so this is like the hop here was less of the technical and more of the tooling side, making it easy to have that kind of end-to-end flow. And so we're seeing kind of coming to a point with the IPFS protocol and the ecosystem where it reached a new level of developers and folks who could access it without having to say go through command line interfaces or interface directly with kind of Hugo from scratch. You could work much more simply with the protocol in a really nice to manipulate way. And actually, one of the groups that came on the scene and drove huge adoption here and I think reached a whole ton of folks in this wider ecosystem was Fleek, who built a very smooth deployment platform where you effectively connect any content address website on GitHub, and it will publish to IPFS and just smooth every new PR to that site, gets auto deployed. It really, we have migrated many of our websites to using Fleek, and it smoothed the developer journey there in some really important ways, which I think is the next step for Web3 in general, is to unlock usability and adoption by new sets of groups by building this sort of tooling that can reach out and support a set of use cases and developer flows that just have been very difficult previously, because we've been spending so much time on the low level infrastructure and capability side of things that we've neglected that end user development flow. And so Fleek has come in and kind of helped solve that problem, which helped catalyze this amazing explosion of D-web sites. So examples of folks who took advantage of that. Ethereum.org went and put their site on IPFS and ENS, so you can view that at ethereum.eth.link. Origin created a whole set of DWeb stores where you can go and buy swag from various different providers. So Brave has put their swag store up on Origin using IPFS, which is pretty cool. There was also this awesome explosion of DeFi sites who are using IPFS to have a fully distributed front end that doesn't rely on any single party to keep that website up, which really helps with the decentralization of sites like Uniswap, Kyber, Ether Wallet, things like that, where, again, the core app, like back end of the application lives in the blockchain, the front end is distributed on IPFS, and you have no central party that's a bottleneck or fully in control of that platform. And kind of this awesome movement of sites into the DWeb culminated with IPFS actually getting default IPFS:// support in Opera for Android in I think the end of March, beginning of May timeframe. And so that was super exciting to see that browser journey and the set of sites that have been being built up in the IPFS ecosystem become more accessible on various platforms that people are using and wanting to access these sites more directly. Looking at Q2, this was our major IPFS release quarter, and so a lot of time spent this quarter was the upgrade and release of these performance improvements, and then also making sure that the tools we used in order to validate and benchmark and optimize the improvements we were making to the protocol also became accessible to the wider ecosystem. So kind of in the April timeframe, we put out IPFS 0.0, which contained a whole ton of different performance improvements to adding data, providing data to the network, finding data within the network, and then finally fetching that data from various peers. One of the big pieces of this was refactoring and cleaning up the IPFS DHT. As the network had grown 30x in 2019, we definitely hit a number of scaling challenges, and so this refactor helped clean out a number of nodes within the network that were not doing a good job serving queries, and update some of the logic within the DHT to better identify where content was and search the network better. So one of the first challenges was we had lots of connectivity gaps where people were joining the network, were undialable, and then queries would take a very long time since you'd end up going down many false roads where you couldn't end up dialing the peers at the end of the network to get to the next step. And so by actually segmenting the network into nodes that would participate in the DHT, being servers of the DHT, versus consumers of the DHT or just clients, that differentiated, and we automatically were able to detect whether or not you were dialable and therefore could participate as a good server of the network. That helped us default nodes into the correct configuration for them. So if you're behind like a home local area network and you're not able to serve a query, you wouldn't join the network as a server, and therefore you wouldn't end up being a gap or someone who's not able to effectively forward on queries to their correct destination. And so this helped us in many ways remove a set of nodes who were previously slowing down our queries and having dead ends. Then the next thing we did was we made sure for the good nodes you were connected to, you stayed connected to them. And so this was a lot of improvements, both to AutoNat and to the routing tables within our DHT. So understanding which peers are valuable, where you have open connections, and that you are prioritizing peers and keeping them in closer buckets when you ask them questions and they succeed at giving you what you wanted. And so that helped us avoid removing good peers that we wanted to stay connected to, and avoided a lot of churn in your routing table, which might then cause you to mostly have nodes that aren't well connected in the network. And then finally, this was like the direct query logic within the DHT. We made a lot of updates to our Kademlia implementation that helped us do the hops in the network, where each time with our DHT, looking a set closer to the nodes that are likely to have the content that you're fetching. And so we improved our query time. We tested this super heavily. This is a very core part of whether the DHT is functioning or not. And so upgrading this required a lot of validation and simulation to make sure that we were actually improving the query logic. But this helped us vastly improve the speed at which we were able to find the content desired in the network. So as I was mentioning, we needed to do a lot of testing and a lot of simulation in order to make these changes. These are pretty fundamental changes to our DHT implementation, and deploying those to a network of millions of end users and hundreds of thousands of nodes and crossing our fingers that it worked was not going to cut it, not even close. And many of these things we couldn't just on a local network, simulate the sorts of changes in a live context that we needed to validate that our improvements were going to be useful. So we actually went and built our own testing framework so that we could do this. And we built it in a kind of abstracted way so it can be used by any sort of peer-to-peer network or protocol in order to do distributed simulation of node jitter and latency and configuration and even version compatibility so that we could evaluate this. And we use that to grab a lot of different data and benchmarks for what those nodes would, how this would perform in a live real network with hundreds of thousands of nodes. And so we ran our new DHT improvements through this over and over again, and it allowed us to optimize. For example, one of the really important and valuable improvements we got here was 20 to 30x faster improvement in providing data to the IPFS DHT. Still a lot of room to go here, still a lot more we can do to make this even faster. But these sorts of massive changes, when viewed within our testing framework, were helped us validate that we were on the right track. Similarly, when we're finding providers of the content we're looking for, we were able to make 2 to 6x faster improvement for fetching data from IPNS, which is our mutable naming system that's built on top of IPFS. We were able to get approximately 5x faster. And then actually for IPNS over PubSub, which was something that we added as part of 0.5 and then stabilized kind of the release after, we were able to make putting and getting with IPNS also a ton faster. Still more improvements there as well, but able to refactor a system that had some significant performance hiccups into something that works pretty reliably. So in all, we were able to look across IPFS 0.4.23, which is our release ahead of IPFS 0.5. And this one, we were able to see really, really massive performance improvements for finding data in the network. Went from somewhere from 8 to 42 seconds, which was just unbelievably slow and very, very painful, to sub-second in most cases. And now we're seeing, I think, 95th percentile as of now. As more nodes in the network upgrade to the latest versions of IPFS, this continues to get faster and faster. So I think we're seeing even better metrics than this, where 95th percentile content routing is now below 3 seconds, which means that the vast majority of queries in the network are completing very fast and are able to, again, still we would like to see these in the millisecond timeframes for many use cases like loading pages, but huge improvements here from where we were at the beginning of the year. In addition to finding content in the network, another area we collaborated with Netflix actually to improve was transferring data in the network. So, depending on your configuration, you may, as an IPFS node, be spending a lot of time actually syncing data between other nodes or fetching data from many nodes at once in order to benefit from having this kind of peer-to-peer architecture. And that was the use case and challenge that the Netflix team was working to solve from kind of a CI/CD pipeline platform. And so we made a ton of improvements to BitSwap, which is our data transfer algorithm, in order to be more efficient with fetching content from many nodes at once, so that you could quickly sync content from, say, a whole array of nodes to spin up a new a new build or new CI/CD node, and it helped remove a lot of the wasted bandwidth of asking multiple nodes for a block and then getting that block from everyone and then ending up with a lot of duplicates. We were able to bring that way down and also increase our parallelism and throughput, which is great. As part of that, from a content exchange perspective, we also added some very early support for GraphSync. GraphSync is the data transfer algorithm that was developed kind of in part thinking directly about blockchains and how blockchains want to exchange content with the network, where you have very deep chains of parents, and you want to make sure that as you're fetching data, you're able to kind of pull each incremental block, not with a round trip in between where you get the parent, then you ask for its parent and its parent and its parent. You want to make one direct query all the way through the history of the network. GraphSync has a selector language that allows you to effectively do like a send me all parents of this node sort of request, and then sync all of those back and forth. And so there's ongoing work in progress to work on bringing GraphSync and BitSwap closer together, but we added responding to GraphSync requests as part of IPFS 0.5, which kind of brought some of those capabilities to IPFS as well. For the people who have really massive amounts of data, and just in general, this is a super useful tool that can be used in a whole ton of different ways, but from a content routing or from a content exchange perspective, super useful is the ability to actually export whole graphs of data reliably and then import them. And so this is actually really useful in the Filecoin case and also in kind of an offline data transfer case where you have really massive amounts of data, where what you really want to do is export an entire graph of data and then import it on the other side instead of, say, sending it over a wire. Maybe you want to put it on a USB and mail it to someone because it'll honestly be faster. And so this was added also to kind of the performance improvements within IPFS. We also added a number of important things from an ad performance perspective and from a hardening perspective. So some of folks here may have heard about the improvements to Gossip Sub, which is the kind of peer-to-peer gossip exchange protocol that's used by many blockchains who are using libp2p as their peer-to-peer networking layer. And this also used a ton of the testing using TestGround in order to simulate a number of attack scenarios and validate and make improvements to Gossip Sub that could then prove resilient to those sorts of attacks. And so worked with a number of different groups, Ethereum, Filecoin, and others to identify the sorts of attack vectors we needed Gossip Sub to be resilient to, simulated those attacks, made those improvements, and then we're able to demonstrate using TestGround that Gossip Sub was now resilient to those, and put out a paper as well on kind of the Gossip Sub v1.1 spec, which is now what blockchains like Filecoin and ETH2 are running on top of, which is really awesome. Cool. Looking at Q3, this was a quarter of standards. And so we took a number of protocols that had either been experimental or had been kind of on their way to being phased out and started making them default. So the quarter of defaults, we added quick support by default. This had been kind of experimental in IPFS for a long time and is now the default. So the quick spec had been evolving. Finally, things solidified around draft 28, and we were able to solidify that and make it the default. And it adds a number of benefits around using fewer resources and therefore and being able to maintain revive connections much more quickly, which is really great. We also added TLS by default. So we now have kind of a default standard security transport, replacing SecIO, which was kind of our, before TLS 1.3 was solidified, kind of our version of it, which in addition, we then deprecated so that we were now using TLS 1.3 and also added noise support so that we had cross implementation support, including in browsers where kind of libp2p over TLS isn't available, isn't an option. And so now we have implementations in noise across browsers, and we have TLS 1.3, which is the default when you're working between, say, like Go IPFS or Go libp2p nodes. And then we're able to deprecate SecIO, which is also very exciting and means that we also, very much encourage people to be upgrading to these latest security transports and to stay connected to the newer nodes in the network who are now using different defaults. I think TLS was added to Go IPFS nodes back in early 2018. And so if you are more than 2 years old, definitely make sure that you are upgrading on the network because newer nodes you'll no longer be able to talk to them if you do not have TLS support. Another thing we worked on standardizing in Q3 was the unified pinning service API. There's a number of different pinning services that have grown up on IPFS. There's Infura, there's Pinata, and there's a number of others. And we are working to bring these groups together and create a unified API so that any application can kind of have a seamless interface and support multiple pinning services all at once using the same API. And simplifies the development experience and makes it easy to have kind of give more of that optionality to the end user of an application. And we've been working to integrate this in the IPFS web UI so that you can, you're uploading files to your local IP, load them up to a pinning service and kind of that redundancy and resiliency by default, which is really nice. And then finally, not within IPFS, but IPFS and IPNS were both added as registered protocol handlers in Chromium. And so in many places where you have Chromium-powered browsers, which is at many places at this point, those are now available to be added and registered there, which is a great step for web browser support. Speaking of new friends, we spent a good bit of time documenting some of the awesome groups who are building on top of IPFS so that they could share kind of both what brought them to IPFS and what their development architecture and story looks like. We have a lot of different people who are using and building on IPFS in different ways. So if you are excited about starting your own thing on IPFS and you want to learn from the motivations and the kind of upgrade path of other people building on the platform, this is super useful. And there's a lot of good information within here about groups like Fleek and Audius and OpenBazaar and how they architected themselves on top of IPFS. Benefiting from that and kind of in parallel to that as well, Filecoin Ignite, which started in the July timeframe and is ongoing with a number of different programs from Gitcoin Apollo to Tachyon's Filecoin Launchpad and HackFS with ETH Global, all brought a ton of new projects and teams to our IPFS ecosystem and kind of stack here using IPFS, using libp2p, and using Filecoin. And so we saw over 100 new projects building on IPFS just within Q3. I'm sure this is continuing to grow, and that was amazing for us as both like a feedback loop of many different teams building on top of the project all at once, and also kind of finding their own niches and being able to help and support each other. It's been great to see these teams come out, and many of them are kind of continuing and formalizing these things with even deeper accelerators and becoming like very stable parts of the ecosystem, which is super exciting to see both that kind of top of funnel adoption and help us improve the developer journey to make it easier and easier over time. I'm almost out of time, but Q4, probably the main thing that many folks already know about was all of the work of launching the Filecoin mainnet. Was a really awesome moment for the entire interplanetary stack and all of the protocols that are used within Filecoin in order to kind of make that network successful, and also for many people in the Filecoin ecosystem who are also kind of making development kind of within the IPFS ecosystem, utilizing Filecoin for longer term persistence and storage. Many of those groups also launched improvements and tooling that makes that easy from a development perspective. If you want to hear more about the ways we contributed to or how we see this evolving, really recommend watching the talks from Filecoin Liftoff Week on the Filecoin YouTube channel. They're phenomenal. We also saw a couple of other groups launch awesome protocols on top of IPFS. Audius launched in the October timeframe with over 1 million monthly active streams. And ETH2 actually just launched yesterday, which is awesome. And they're using libp2p and actually have funded and helped create a number of different libp2p implementations. And there is now 4 client implementations interoperating on the Beacon chain. So huge thank you to these teams for like helping push libp2p forward and making it better. Super exciting. Cool. And my call to action for you in my last minute is we are actively working on IPFS 2021 planning. There's a lot of stuff happening in the ecosystem and a lot of ideas on how we can continue to make it better and where we should focus our time as, both some of the core working groups and then also this entire ecosystem of awesome projects who are trying to work within the IPFS ecosystem and make it better. And so 15 proposals already, awesome conversations happening. Please jump in if you want to talk about IPFS 1.0 or content permissioning or new DHT improvements. Come join the conversation. We would love to hear your thoughts. Cool. Well, my sneak peeks will then be sneak peeks in 2021 when we actually have more to share. And thank you guys so much for your time. Feel free to message me on Twitter if you have anything going on.
Awesome. Thank you so much, Molly. The work you and your team is doing is so important to the community. Amazing to see the amount of companies contributing and participating in the IPFS ecosystem. The future is certainly bright. We're absolutely thrilled to have you here. Thank you so much.
Absolutely. Thank you guys so much for having me.
We have 2 questions in our Q&A for you. First question, what's the plans for merging IPFS and Filecoin ecosystems?
Yeah, I would say a lot of this is organic. Like it's just honestly happening on its own accord. And it started, over a year ago. Lots of groups within the IPFS ecosystem were already looking to things like Filecoin or were attracted as that is an upgrade path for them for keeping data storage around and accessible. A number of groups who have been building developer tooling and APIs with the system, Infura, Textile, Fleek, others have already dived deep into Filecoin and are some of on how to configure, use it from a developer. And so this is well underway. Definitely go look at some of the videos. These groups are highly overlapped, and in many ways, using Filecoin is using an IPFS node. It runs on top of the same protocols. It uses libp2p. It has IPLD data. To add new data to the Filecoin network, you first turn it into IPFS shaped data and send it over libp2p to people. So in many ways, these are already very shared ecosystems. Obviously, like not all IPFS use cases are going to utilize Filecoin, which is awesome and perfectly fine. But like we see these as very overlapped and complementary.
Awesome. Apart from Fleek, what is your personally favorite project using IPFS?
I spent a while thinking about this last time, and I avoid picking favorites in the IPFS ecosystem because I love all of them and they're doing really, really amazing work. The one that I'll actually shout out to, which is not technically in the IPFS ecosystem, is Matrix. I guess now called Element. I love their team. They're just phenomenal. They think really thoughtfully about kind of the content moderation and agency of nodes in the network. And they've actually started building a P2P matrix or P2P element on top of libp2p, which is super cool. And I'm really excited to see where that one goes.
Awesome. Thank you so much for your time today. Greatly appreciate it.
Absolutely. Thank you so much.
Take care.
Thank you.
Awesome. So before we kick off into our next presentation, we're going to take a quick about 5-minute break and we'll head back to the floors. So stay tuned.